So today we're going to continue with the prerequisite chapter. Today we're going to cover section 4. We're actually going to split it up into multiple days. So today is part 1, and we're going to start factoring polynomials. We're going to first start out with just a GCF, a greatest common factor. So a greatest common factor, what we'll be doing is we're going to look at all of the terms in our polynomial, and we're going to look to see if there is a greatest common factor. So in this example here, I'm going to look at the 6x to the third. I need to look to see if there is a greatest common factor between the coefficients and between the variables. Notice they both, if I look at 6 and 4, I know there's a greatest common factor of 2. And I can see that they both have an x, so they also have an x in common. And now what I do here is I divide both of my terms here by the GCF. So I'm going to divide this one by 2x, this one by 2x, and then in the parentheses here, I'm writing what I get when I divide. So when I divide this one, 6 divided by 2 is 3. And then remember, when you divide, you subtract exponents when the bases are the same. So this would become x squared. And then when I go to do this one, 4 divided by 2 is 2. And then x to the first minus x to the first, I would get 0, which is 1. So I just write 2, and I'm done. So once you determine what the GCF is, and you divide each of the terms by that GCF, that's what remains in the parentheses. Now, again, what you can do is you could distribute this back, and it should go back to the original problem. Now, after you divide, what's left in here, if there's still a GCF in there that you could have pulled out, then perhaps you did not find the greatest common factor. So there might have always been a larger one. Let's try some more examples of these. Now, whenever your leading coefficient, so this number that's in front of when your equation is in standard form, if it's negative, then I'm going to pull out a negative greatest common factor. So I'm going to look at all three terms. I'm going to look at all the coefficients. I'm going to look to see what would be the common factor that they all have. I can all see that they all have 4. They all have 2 in common, but that's not the greatest. So my greatest common factor here is going to be -4. Notice I'm going to go and look to check their variables. The first one has an x squared, the next one has an x, but the 16 does not have a variable. So there is no variable in common. So I'm going to put my GCF out front, which is -4. And now in parentheses, the results of dividing each one. Here I'm left with x squared for the division on this one. Here I'm going to be left with -3x. And then the last one is going to become +4, negative divided by a negative. And I'm done. Now, later on, right now, for this one, we can't factor this one any further, but once we learn how to factor trinomials, this potentially could be continued to be factored, but I can't do this anymore. So today, right now, we're just doing a GCF. The next one, again, I'm going to look at my coefficients. I'm going to find the greatest common factor. I can see that the greatest common factor is going to be 3. Then I'm also going to look to see if they have any variables in common, and I can see that they all have x. So my greatest common factor here is 3x. Now, you don't need to show the division here. You can just know that you're dividing by the GCF. I like to give myself a visual. All I need to see here is what you're getting with the GCF outside, and then what results after you divide. So the first one, 3x cubed divided by 3x is just x squared. Then the middle term, negative 6x squared divided by 3x is negative 2x. And then 9x divided by 3x is just 3. And I'm done. Again, I cannot factor this trinomial. Again, we haven't covered that yet. That's what we'll be covering, I think, in part 3. Next, now this one looks a little complicated, but we're still doing exactly the same thing. Notice my greatest common factor here is the x minus 2. So I'm going to divide both of them by x minus 2. So that's my GCF. It goes out front. And now what I get after I divide is 2x plus 3. So that would be the final answer here. So your GCF does not have to be a monomial. It could be a binomial. Same thing on the next one. My GCF here is the x plus 3. So I'll write that GCF on the outside, and now I'm going to write what I have left over after I divide. So this could take away one of them, and then here I'm left with just the 4. I can combine my like terms here, and I'm left with the x plus 3, which was the GCF, and then positive 3 minus 1, minus 4 is negative 1. So these last couple examples, the last two on this page, might be something that maybe you did not see in your Algebra 1 course. But again, examples 1 and 2, that should be something common that you're used to. The next thing we're going to talk about factoring today is the difference of two squares. So the difference of two squares, when the two terms of a binomial are perfect squares with a minus between them. This is where the name comes from. Difference means subtraction. So when you have two perfect squares and there is a minus sign or a subtraction sign between them, that is going to be an example of the difference of two squares. The fastest way to do them is to square root the first and the last terms. One parentheses gets a plus sign and one will get a subtraction sign. So notice in this example, x squared is a perfect square and 4 is a perfect square. Notice in between the two perfect squares is a subtraction sign. So the way that we would actually factor this is we're going to do what it says here. We're going to square root the x squared. We're going to square root the 4, and then I get, actually let me just do this in blue. We get a 2. We're going to write that in both binomials, but one gets a plus sign and one gets a minus sign. When I FOIL this, that's the way that you will check when you are going to factor this difference of squares or trinomials. You can FOIL this and it needs to go back to this. If it doesn't, you've done something wrong. So for example, if I FOIL it, x times x is x squared. Outside gives me negative 2x. Inside gives me positive 2x. And last gives me negative 4. These two cancel out, and it does go back. Now, you don't need to do this step that I just did, but I highly recommend it if you do have time, because it will catch careless sign mistakes. What I recommend when I'm teaching this to Algebra 1, I recommend that my students memorize perfect squares up to 20. And what I mean by that is 1 squared is 1, 2 squared is 4, 3 is 9, 16, 25, 36. Know all of these all the way up to 20. That way, when you're given a binomial like this, if you already can recognize perfect squares, it'll make the problem a lot easier. Then immediately you know you just have to square root both terms. So in example 5, notice I can recognize that 9x squared is a perfect square, and so is 49. So again, I'm going to, when I factor, I'm creating two binomials. The first term that's going to go right here and right here is going to be the square root of this one, the first term. So I square root 9x squared. Square root of 9 is 3. Square root of x squared is x. So I'll write that both there. And again, remember when you're factoring the difference of two squares, one is going to get a plus sign, one's going to get a minus sign, and then the second number that's going to go here is the square root of 49. So 7 and 7. Again, you could FOIL it to double check that it does go back, and it does. The next one, again, remember you're creating two binomials. 36x squared is a perfect square, and so is 49y squared. So again, I would square root 36, and it's 6. Square root x squared, I get an x. Put both of them right there. Again, one gets a plus. Now, the order that you put the plus minus sign, it doesn't matter. Notice on number 5, I put the addition sign first and then the subtraction. The order that you put these signs doesn't matter. Okay, so you could write the addition binomial first or the subtraction. You're still going to get the same answer. Then I need to square root the 49y squared. Square root of 49 is 7. And I also need the square root of y squared, which is y. Now, before you even begin, you should always look for a greatest common factor. Now, at first glance, you're going to look at this and say, well, 4 is a perfect square, so is 100. If you just square root it, watch what happens. If I just square root the 4, I get 2, 2x, and 2x. And again, I could put my plus sign, and then if I square root the 100, I get 10. Now, whenever this occurs, and there's still a GCF in here, you needed to first pull out a GCF before you factor. So let me go back and start all over again. So now, what I would have to do is divide both of these by 2. But let me show you the correct way to do this is you need to look for a GCF first, and then you factor the difference of squares. So what I need to do here first is always look to see, is there something I could divide both of these numbers by before I begin my process of the difference of two squares? Notice they both have a greatest common factor of 4. So I'm going to put the GCF here. And then the answer to that division is going to be x squared minus 25. Now, I still have the difference of two squares in this parentheses because I can assume a coefficient of 1 here, and 1's a perfect square. So now I have to factor this, and again, I would square root the x squared. This gives me an x. And then I square root the 25, and that gives me a 5. Again, one's a plus sign, one's a minus, and then the GCF you pulled out needs to come down in front. So this answer is right here. It's 4 times x plus 5, x minus 5. If you would have done this, you're going to get it wrong because this can still be factored further. So be careful. Always look for a GCF. The next one. Remember the name of this section. It was called the difference of two squares. Notice this problem has a plus sign. There is no such thing as the sum of two squares. So for this one, you would say cannot factor. There's no GCF to pull out, and you cannot factor the sum of two squares. If you were to make both signs addition signs in your factors, you would get a middle term. So there is no such thing as the sum of two squares. So you just say cannot factor, and if this were a question and it was multiple choice, chances are they would just have the problem rewritten as an answer choice. So if it's a free response question, you're either going to just tell me you cannot factor it, or you'll rewrite the problem because it's already simplified. Now, let's change up number 7, and I just want to modify it a bit to show you something different before we move on. Let's say we take this same question, x squared plus 100. Now, let's say in this case, they give you this, and at first glance you're like, oh, wait a minute, they're perfect squares. It's an addition sign. I can't factor this. However, what you can do on this problem is just pull out a GCF. So here I would divide both by 4, and then I would be left with x squared plus 25, and then you would stop here. Because now this is the sum, and there's no GCF, so you stop. This would be the answer that's factored. So be careful. Don't automatically assume that you see perfect squares, and if you see an addition sign, it can't be factored. Always, always, always look for a greatest common factor first, and then proceed with what's left. Let's try the next one. X to the 8th is actually a perfect square because I can square root it. Remember, when you square root variables that have exponents, remember the index that's assumed on a square root is a 2. So when I square root x to the 8th power, I'm dividing it by 2, and that's going to give me x to the 4th. So when I go to factor this one, I'm going to square root x to the 8th, and that'll give me x to the 4th. I'm going to square root 1, and that gives me 1. And remember, 1 gets a plus sign, 1 gets a minus sign. Now, whenever you're factoring any type of problem, you always need to factor completely. If you look at this one right here, I can continue factoring this one. It's still the difference of two squares. This one is done, so I'm just going to keep writing it in my answer. This one, I'm going to break down. Again, I'm going to square root both terms. So when I square root x to the 4th, I get x squared. When I square root 1, I get 1. And again, 1 gets a plus sign, 1 gets a minus. Notice I'm still not done. I still have a binomial that is the difference of two squares. I can keep going on this one. These guys are done because there's no such thing as the sum of two squares, and I can't pull out a GCF. So let me just rewrite this one, and now I factor this one. Two binomials, square root x squared, it gives me an x, square root the 1, and 1 gets a plus sign, 1 gets a minus sign. Now I'm finally finished. And that would be my final answer. Now, if you were to FOIL and then distribute, it would go back to this. Let's try the next one. Again, it's got a subtraction sign, so I know it's going to be the difference of two squares. First thing I should do also, though, is look to see if there is a GCF. There is no GCF, it's only a 1, so I'm just going to square root. So again, you're making your two binomials. I'm going to square root 625. The square root of 625 is 25. And then when I square root x to the 4th, I get x squared. Again, 1 gets a plus sign, 1 gets a minus, and then I square root the 1, which is 1. Again, I'm going to check to see, can I still continue factoring? The first one is done, because it's the sum of two squares. However, this one, I can factor again, still the difference of two squares, square root the 25, x squared, and I get 5x, square root the 1, and I get 1, and then 1's a plus sign, 1's a minus sign. And now I'm done. I can't factor any further. Try the next one. Notice when you first look at number 11, it's not two perfect squares. However, I can factor out a greatest common factor. So my GCF here is going to be 3. So I'm going to write this as my GCF. What I get when I divide, which will be 1 minus 4x squared. And now, even though it's written backwards with the 4x being subtracted from the 1, this is the difference of two squares. Because again, 1 is a perfect square, and so is 4x squared. So now that I've pulled the GCF out, now I need to factor that further. I will write the GCF. I will square root the 1. Square root the 1, and then 1 gets a plus sign, 1 gets a minus, and then I square root the 4x squared. 2x, 2x. And now I'm finished. Don't forget about that GCF. You need to continue bringing it down into your answer. Number 12. Notice I have two perfect squares. Okay, I know it looks a little strange when you have a binomial that's squared, but these are perfect squares. So again, if you do the same thing, two binomials, one's a plus sign, one's a minus, square root this, becomes x plus 2, x plus 2, square root this, and it becomes y. And you're done. Let's try another one like that. Same idea here. Two binomials, these are perfect squares. Square root this, I get x minus 1. Square root this, I get 3y squared. One's a plus sign, one's a minus. 3y squared, 3y squared. No like terms to combine, you just leave them like this. Again, if you multiply these two trinomials back, it will go back to your original problem. Next one. These are both perfect square numbers. However, if I don't realize that there's a GCF that I can divide, I'm going to have to go back and restart again. I can divide both 81 and 36 by greatest common factor, and that's going to be a 9. So I'm going to GCF, get what after I divide 81 by 9, 9 is left. 36x squared divided by 9 is 4x squared. I still have the difference of two squares in here, so I got to break it down. Let me write my GCF, get ready to set up my two binomials. Square root of 9 is 3. One's a plus sign, one's a minus. Square root of 4x squared, 2x, 2x. And now I'm done. Next one. Difference of two squares. No GCF to pull out. Set up your binomials. Square root this, x squared, plus sign, minus sign, square root the 16y squared, and you're done. I can't take this one any further because it's not a y squared. Next, we're going to talk about perfect square trinomials. This is what results when you have a binomial squared. So what you can do here is you're going to test. You're going to square root the first and last terms and then double the product. If this is the middle term, then all you have to do is square root the first and last terms and then take the sign from the middle. So let me show you what that means, what I mean by what all these words are here. This is the way that you can check it. Now, you could also say, well, I'm going to practice with my factoring of trinomials, look for the factors of 25 that will combine to give me -10. But the trick here, it says you're going to take the square root of the first term, which is an x, the square root of this one, which is 5. I'm going to multiply them, and then I'm going to, and then double the product. So x times 5 times 2 is 10x. If it gives you the middle term, then we know that it is a perfect square trinomial. Now, what we're going to be learning in Algebra 2 Honors is when I square root a number, it actually gives me two results. It actually gives me +5 and -5. So in this case, I'm going to be using the -5, so I get the -10 middle term. So since my test worked out, I square root the x squared, I square root the 25, and then I put the sign in the middle. And it's a binomial squared. Or you might see the answer written like this. Let's try the next one. So we're going to test this. Square root the 16, x squared, and I get 4x. Square root the 9, I get 3, and then I double it to see if I get the middle, which I do. So now this tells me it is a perfect square trinomial. So all I have to do is square root the 16, x squared, square root the 9, and then it's a binomial squared. Try the next one. Square root the 9x squared, I get 3x. Square root the 25, I get 5. Double it, I do get 30x. So what came out of here was a -5. I take the sign of the middle. So my final answer here is going to be 3x minus 5, and then the binomial is squared. Next one, let's do our check. Square root, square root. Square root of 4x squared is 2x. Square root of 1 is 1. Double it, and it does give me the middle. So again, it is a perfect square trinomial. 2x plus 1 squared. Now, it doesn't always work. That's why you have to check that when you square root it, you do get the middle term. Because if you don't, then it's not a perfect square trinomial. Let's try the next one. I'm going to test. Square root, get 6y. Square root, I get 7. Double it. 6 times 7, 42. Times 2 is 84. It works. So I just do 6y plus 7 squared. Let's try the next one, see if it works. Square root this, I get 3u. Square root this, I get 4v. And then times it by 2. And then this would be 24. Notice this is missing a uv. So this one you could say you can't factor it. There's probably a typo. Let's put a v there. So it does give me the uv in the middle. So then this would just become 3u plus 4v. And it's squared. So that is it for the special products. So again, we have the difference of two squares, and then we also have what results is a perfect square trinomial. And those you can use tricks. However, when we get to factoring the trinomials, you don't necessarily have to do these tricks. You can also do it the long way, which we're going to be probably learning on day 3. So tomorrow, I believe we'll be doing perfect cubes, and then just getting into this factoring. The best way to be successful with factoring is to do practice. Practice, practice, practice.
And we don't turn in the notes, right?
Right, you don't turn in the notes. You do have a homework assignment. Let's go ahead and take a look at that.